Welcome to another session. In this session, I'm going to talk about control measures of air pollution. In the previous few sessions, we have studied in detail about air pollution, causes and sources of air pollution, and then about the effects of air pollution on humans, plants, animals, and on the weather. We know that prevention is always better than cure. And from the previous few sessions, we have come to a conclusion that air pollution is deadly, and when continuously exposed to air pollution, it can cause severe health issues. The recent decline in the air quality of major cities and also the variation in temperature are all results of air pollution, and therefore the control of air pollution is very important. To talk about the controlling measures to control or put an end of air pollution, we have to study various ways in which we can use technology to put an end for air pollution. Before that, let us see what are the other ways to put an end of air pollution. Say, for example, we know that the major pollutants, like the oxides of sulfur and carbon, are all emitted from the vehicles and industries. So, replacing the raw materials by the materials which contain less of sulfur and oxides of carbon or carbon can put an end for the air pollution to an extent. The other way in which we can reduce air pollution is by zoning. So zoning is something where you divide the areas based on the purpose. Like you divide the areas into residential areas and industrial areas. Thereby, you can improve the quality of air at least in the residential areas. Now let us see what are the different methods in which we can use technology to control air pollution. Coming to the first method, we have settling chambers or the gravity settling chambers. Now, here we have a picture of settling chambers. Settling chambers are actually very effective for removing the coarser pollutants or particulate matters from the air. So here in the settling chambers, we actually use the force of gravity to remove the solid or coarser pollutants. Now, the air which contain the pollutants or coarser particles enters into the chamber. Inside the chamber, the velocity of the gas is gradually reduced, because of which the coarser pollutants settle down into the hoppers. It is collected in the hoppers, and the clean air come out through the outlet. So this is how the gravity or settling chamber works. So it is very effective for removing the coarser pollutants. It is almost 99% effective in removing the coarser pollutants. The air which contains the pollutants enters into the gravity chamber through the inlet, and in the chamber, inside the chamber, the velocity of the gas is gradually reduced, because of which the coarser particle will have a tendency to settle down and it is collected in the hoppers here. The clean gas then goes out through the outlet. That is how the settling chambers work. Coming to the second method, we have cyclones or cyclone separators to remove the particulate matters. So here in the case of cyclone separators, the principle of inertia is used to separate the coarser particulate matters from the air. So the air enters inside the chamber, and then the gas is forced to move in a different direction. Whereas at the same time, the coarser particulate matters which is present in this air will continue the inertia. Because of its inertia, the particulate matters will have a tendency to continue in the same direction. So when the gas tries to move in the opposite direction, and the particulate matters, because of its inertia, will have a tendency to move in its original direction. So because of this, the particulate matters get separated and it is settled down at the bottom of the cyclone. So here the air which contains the pollutants enter inside the chamber of the cyclone separators. So due to some action inside the cyclone separators, the gas will be forced to move in a opposite direction. But at the same time, because of the inertia of the particles, coarser particulate matters inside the gas, it will have a tendency to move in its original direction. So the gas will be forced to move in the opposite direction, wherein the particles or the particulate matters will continue to move in the original direction. So, because of this, the particle or the particulate matters, the coarser particles which are present in the air, will be separated and will be settled at the bottom. The clean air will move out of the cyclone separators at the top of the cyclone separators. So that's how actually the cyclone separator helps to remove or separate the coarser particles. But here the disadvantage of the cyclone separators is that it can only remove the coarser particles. It is very bad or weak in removing the smaller particles which are present in the air. So it is always used along with other control devices. If you want me to explain the operation again, the air which contains the pollutants enter inside the cyclone chamber. So because of the action inside the cyclone chamber, the air which enters inside is forced to move in the opposite direction, but the particles which is present inside the gas or air which is inside the chamber will continue to move in its original direction because of the force of inertia. So because of this change in direction of motion, the particles or the only the coarser particles will have a tendency to get settled at the bottom of the chamber. So it is then removed. The clean air then enters out through the outlet. So this is how the cyclone separator works. In the next method, we have wet scrubbers, which is also called as wet collectors. Now, wet scrubbers or wet collectors are cleaning devices, air cleaning devices, which usually uses a scrubbing liquid in it to separate the particulate matter from the air. So here a liquid is injected into the wet scrubbers, which joins with the particles or the particulate matters which is present in the air and is separated out. Venturi scrubbers are actually an example of wet scrubbers. So let us see how it works. So here the dust or the air which contain the pollutants or coarser particles are introduced into the wet scrubbers from the top. At the same time, the scrubbing liquid is injected at the throat of the wet scrubber. So when it is injected into the throat, the velocity at the throat of this scrubbers will be very high so as to break down this liquid into atomized particles. And this atomized liquid particles of the scrubbing liquid joins along with the particulate matter and is then together collected at the bottom. So that's how the wet scrubber remove the dust or the particulate matter. It is a very effective cleaning device. To explain the procedure again, the air or the dust which contain the particulate matter is introduced at the top of the wet scrubber. At the same time, at the throat, you are injecting the scrubbing liquid. You are using the scrubbing liquid to separate out the dust from the air. Okay, so the scrubbing liquid is injected at the throat and the velocity of the wet scrubbers at the throat will be very high, and because of this the liquid will be broken down into atomized particles. This liquid atomized particles will then join with the particulate matter, and together the particles will be collected at the bottom. The clean air will then be separated. So that's how we use the wet scrubbers to clean the air. In the next method, we have electrostatic precipitators. So here, the electrostatic precipitators usually separate the particulate matter which are present in the air by charging the particulate matter, and then it is attracted by using high electric charges. Okay. So here it is electrostatic precipitators are usually very effective compared to all other methods. It can even separate the very fine particulate matters or particles from the air which is flowing inside. So here The particulate collection device usually removes the particles from the gas which is flowing using the force of induced electric charges. So the particulate matters are usually charged, a high electric charge, using a high electric charge, and then this particulate matters are usually attracted by using high electric charges. So it is first, initially it is separated, so the gas enters or flows inside the electrostatic precipitators where it is charged and further attracted by using high electric charges. At last, we have fabric filters. So fabric filters or bag houses are very effective, and it removes almost 99% of all the dust or particulate matters which is present in the air. But one disadvantage is fabric filters can't be used at very high temperature, is that high temperatures often have to be cooled before contacting with the filter medium. I mean, if the air is at coming or entering inside the fabric filter at very high temperature, it have to be cooled down before you filter them. So here, the air which contain the pollutants is actually made to enter inside the fabric bag. Inside the fabric bag, you have a number of filters arranged. The filters is usually made up of fabric, usually cotton, synthetic, or even glass fiber materials. The air passes through these filters, and the dust or the particulate matters are collected at the filters, and the clean air moves outside the fabric filter. So here the air enter inside the fabric bag. Inside the fabric bag, you have a number of filters arranged. The filters are usually made up of fabric, any kind of fabric like cotton, synthetic, or even glass fiber materials. So when the air passes through the fabric, the dust particles are collected or caught inside the filter. The clean air moves outside. Only disadvantage here is it can't be used at high temperature. If the gas is at enters at very high temperature, it has to be cooled down to filter them. So that is about the different ways in which you can use technology to control air pollution. In the next session, we'll discuss about water pollution. So that's it for today.